notes, here I am. Take a notebook out, let's start the jam. Video notes, here we go. Take a notebook out, let's start the show. Video notes. Video notes. Hello everybody, and welcome to this edition of Video Notes for Mr. Flugum's General Chemistry class. That is Gen Chem. And these notes, you guys, will go on page 9 in your science notebook. Thanks for tuning in. Let's go ahead and get started. Okay, so as we get started, let's kind of talk about this. Let's talk about matter. Okay, so matter is basically this, right? Anything that takes up space. So air is matter, right? Water is matter. Solids are matter. And everything that is made of matter is made from atoms. Let me finish this here. So here is a picture of an atom. We'll get into atomic structure in the next unit, but just to give you a basic kind of view of that, there is an atom, and everything that is matter is made up of atoms. Okay, so this is the periodic table here. It has every element in it, starting with the simplest element up here, hydrogen, to the largest element that we know of right here, number 118. These are all man-made, by the way, these really big ones. Okay, and basically all matter is made up of something from this periodic table. Now these are elements, and what's an element? Well, here's the deal. An element is this. I want you to write this down in your notes, right? Element is a substance where all the atoms are the same. And we'll get into that definition a little bit more, but that's important to know, right? In an element, all the atoms are the same. So, for example, if we have a bunch of hydrogen, and we were able to look at that hydrogen closely, all of the atoms in that hydrogen would basically be the same. So when you start putting elements together to make substances, you get what's called a compound. Right? So what's a compound? Compound is this. It is two or more elements that are chemically combined. So, for example, here we have sugar. Here is a big sugar molecule, and sugar is this. It is carbon, hydrogen, and oxygen all together. Okay, is what makes up sugar that we eat. So that is a compound, right? Water would be another example of a compound, as would carbon dioxide. So in contrast to a compound, we have a mixture. So examples of mixtures would be like this Kool-Aid here, or this rock. What a mixture is it is two or more substances that can be physically separated, right? Sorry about that. Be physically separated from one another. For example, with this Kool-Aid here, all I would need to do is evaporate off the water, right? And I'd be left with sugar and food coloring. This mineral, this rock here, I just have to crush it up into small pieces and then separate the minerals from one another. So those are both mixtures, right? Different from a compound. Okay, so let's talk for a moment here about physical properties and physical change. And the key thing here is that when we talk about physical properties and change, we are not changing the identity of the substance, right? So physical characteristics are things that we can observe without changing the identity of it. For example, right, if we melt or boil something, We can tell when that happens and what temperature, but we don't actually change the substance, right? Same with the state of matter and its appearance, such as its color or its texture, right? These are all physical properties, things we can observe without changing it. Likewise, physical change means we do something to a substance that doesn't change its identity, okay? We just grind it up or we change its state. Here's an example of physical change, right? This is a bunch of sulfur, right? Sulfur is a yellow and brittle material, right? And if we just grind it up, well, it's still sulfur, right? That's just a physical change. So just a couple slides back when we were talking about separating mixtures physically, right? That means we separate these mixtures using only physical changes, right? Because we don't change the identity of the substances. And they're not chemically combined, so we don't have to in order to separate them. In contrast to physical changes, we have chemical changes, right? And chemical properties. So in this case, this is something that we do that completely changes a substance into something different, right? So for example, if we observe that something is flammable, we change it into something else. Or if we see how reactive or stable it is, then we see a change that happens, right? Chemical changes can be things like combustion, right? Fire, rusting, so changing colors. And when we digest stuff, that is a chemical change. Now it's important that we understand this as we move forward in chemistry. We need to know the difference between a physical change and a chemical change. So how can we know the difference? Well, here's the deal. An object changes chemically if any of the four things below happens, right? Color change, like this apple. We have flames or heat or smoke. We have a new smell, okay, which maybe is like this apple or the fire there. Or we have gas bubbles being produced. All of those are examples of new substances occurring and chemical change. Okay, so right here is an example of chemical change, cooking an egg. So I'd like you to just think about this, and we'll discuss it really quick in class on Thursday or Friday when these are due, right? What is the evidence that there's a chemical change happening? All right, folks, and what is it? So here's this banana, right? This is what good bananas look like. This is what not good bananas look like, right? So what kind of change is it? Is it physical or is it chemical? Or is it both? Okay, we'll talk about that on Thursday or Friday. Okay, well, thanks for tuning in, folks. Hope you have a great day, and we'll see you on Thursday or Friday. Bye-bye.